90 minutes.
The loss of Challenger in 1986 and of Columbia in 2003 meant that shuttle missions had been canceled for a total of 5 years.
0 and liftoff of Space Shuttle and
Regular shuttle missions resumed in 2006. Its days were numbered. Vulnerabilities in the system could not be redesigned. With the final shuttle flight in 2011, America's space program was in disarray. It had no craft that could carry humans to space, yet it was the major partner in the International Space Station. Towards the end of the space shuttle's life, new designs began to surface. The X-33 was a prototype for a single stage-to-orbit craft that returned to Earth just like the shuttle. It relied on new construction techniques and radical aerospike engines. A second, more cautious group saw the shuttle as an expensive gamble that had not paid off and had killed 14 astronauts. These engineers wanted to return to the expendable capsule and rocket technology that had delivered men to the moon. The X-33 was shelved, and NASA began the Constellation program that followed a more familiar
6,
path.
5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Constellation envisioned a family of Ares rockets that could be configured for flights to the ISS or for more demanding missions to the Moon and even Mars. Launched in 2009, Ares 1X was the only flight of the Constellation program. Vibration was extreme, and eventually this project was dumped too. The Crew Exploration Vehicle, which later became the Orion capsule, is the only part of the Constellation program to survive. It is the spacecraft that will take humans back to the Moon. But NASA decided that missions to the International Space Station should have a different spacecraft. Even as the ISS was under construction, unmanned Russian Progress cargo ships had been delivering supplies. They rendezvous and dock automatically. In 2008, ESA's automated transfer vehicle began resupply missions, followed in 2009 by the Japanese Kounotori resupply craft. The Kounotori has to be captured manually by the station's robotic arm. In 2012, almost a year after the shuttle's retirement, the first American resupply craft arrived. This was SpaceX's Dragon capsule. Like the Japanese craft, it had to be captured by the station's robotic arm. The Dragon capsule differed from the other cargo craft in one significant way. Packed with refuse at the end of their operational lives, the other cargo craft were discarded. After release from the ISS, they were sent to burn up over the Pacific Ocean. But the Dragon had a heat shield and parachutes. It could safely re-enter the atmosphere and be recovered. Clearly, the designers were thinking ahead. It made business sense, too, as SpaceX earned extra revenue from returned science cargo. In addition, the capsule could be reused. In 2010, NASA instigated a competitive program for corporations with expertise to develop human-rated spacecraft for flights to the ISS. The space agency wanted to focus on deep space exploration and simply pay corporate partners for services to and from low Earth orbit. In 2014, SpaceX and Boeing were awarded contracts to build spacecraft and to fly missions. Boeing is a company with a long involvement in aerospace engineering, and it has a long involvement with NASA. As far back as the Apollo program, Boeing built the first stage of the Saturn V. The other stages and the Apollo spacecraft were built by companies that have since merged with or have been acquired by Boeing. In addition, Boeing is an equal partner in the United Launch Alliance, a joint venture with Lockheed Martin that launches the giant Delta IV and the Atlas V.
3, 2,
By contrast, SpaceX's first successful launch had only happened in 2008, and when the commercial crew contracts were awarded, SpaceX had just 15 successful launches to its credit. NASA had intentionally chosen two companies to develop two distinct spacecraft in a strategy they called dissimilar redundancy. The space agency did not want to have all its eggs in one basket. A problem with one spacecraft might see it grounded, while the other could continue in service. It was inevitable that the simultaneous development of two new spacecraft would be seen as a competition. Soon, infrastructure at Cape Canaveral was leased by the two companies. Boeing took over the old shuttle processing facility and rebranded it with a new paint job. The United Launch Alliance already had access to Launch Complex 41 for the Atlas V, but modifications were carried out to enable crew entry to the Starliner capsule that Boeing was building. SpaceX leased Pad 39A and demolished the outmoded shuttle launch towers.
Burn hole! Burn hole!
Old space hands saw the competition between Boeing and SpaceX as very lopsided. Boeing had more experience, and they had been granted more development money. The two companies had to design, build, and verify their new spacecraft, but they also had to satisfy NASA that their rockets were safe for human cargo. Boeing would modify its Atlas V launcher, and SpaceX would upgrade its new Falcon 9 rocket. In 2012, SpaceX began testing a peculiar new rocket. Called the Grasshopper, it was designed to help understand problems associated with propulsive landing. It made 8 successful flights. Soon, a much larger version with dimensions similar to the Falcon 9's first stage began tests. It had retractable landing legs. It made 4 successful flights, demonstrating the ability to move laterally and to recover from intentionally induced anomalies. Things were looking good for SpaceX. They were very close to routinely returning the Falcon 9's first stage for reuse. When Boeing first revealed their new spacecraft, they were proud of its resemblance to the Apollo capsule that had taken men to the moon. It was connected to important American heritage, yet it incorporated 21st century technology. It could accommodate 7 astronauts or a combination of crew and cargo, and it was designed to be reusable. It was called the CST-100, but it became known as the Starliner. One of its most remarkable innovations is that it is designed to return to hard ground rather than splashing down into the ocean. A key requirement for the Starliner is a launch escape system. The most dangerous period in the life of any spacecraft is during its boost to orbit, and for human certification, the new spacecraft must be able to break away from an exploding booster and rapidly propel itself to a safe distance, then gently return to the ground. NASA encourages their corporate partners to design and build the new spacecraft in whatever way they feel will be reliable and cost-effective. However, NASA still has an exhaustive list of requirements that need to be demonstrated before the craft and its launcher can receive certification. While Boeing's Starliner will land on the ground, NASA requires the company to test the craft in water. If a launch abort is triggered, the capsule will return to the sea off the Florida coast, and a test article reveals how the craft behaves during a wet landing.
7, 6, 5.
Experimentation with the Starliner's parachutes also pushed the system beyond its usual capacity. In the fifth and final test of the craft's landing parachutes, the Starliner was again exposed to conditions similar to a launch abort. Parachutes perform well when they are released into a steady flow of air. But during a launch abort, they are deployed into turbulent air. Released from a helium balloon at an altitude of 10,000 meters, the sequence of parachute deployment began while the capsule was falling at a much lower rate than would be experienced after a return from space. To push the system even further, one of the craft's 3 parachutes had been disabled. Despite the increased stress on the system, everything performed well. NASA shares data with its commercial partners, and the parachutes here are similar to those developed for NASA's larger Orion capsule.
Video prepare.
Testing of the Starliner's propulsion system was exhaustive.
5, 4.
The capsule's service module is fitted with 28 reaction control thrusters that are used for on-orbit maneuvering and space station reboost. For orbital and phase changes, 20 more powerful orbital maneuvering engines are also situated on the service module. These will also be activated during any launch abort procedure. At the base of the service module are 4 launch abort engines that will do the heavy lifting during a launch emergency. A further 12 reaction control engines are fitted to the crew module for orientation during re-entry, after the service module has been discarded. The trials were successful until a 2018 test involving the launch abort engines. At engine shutdown, 4 of the 8 propellant valves failed to close, resulting in a serious propellant leak. Resolving this problem caused Boeing many months and serious delays in Starliner development. SpaceX's Dragon 2 capsule is a refinement of the original Dragon intended for cargo flights. Though Boeing has vast experience in the space business, SpaceX's recent involvement in the operation of a capsule that could return to the Earth was an advantage. After 2 test flights, the original Dragon made 12 resupply missions to the ISS using new spacecraft, one of which failed due to launcher problems. A further 7 resupply missions were made using recycled Dragon capsules. All 18 successful missions landed in the Pacific Ocean off the California coast. The new capsule has a longer trunk, and its solar panels have been replaced by a sleeve of solar cells along part of the trunk. A reusable nose cone that pivots away to reveal the docking adapter replaces the old disposable nose cap, and the craft has the ability to dock automatically. The whole safety regimen, centering on the capsule's abort system, presented similar problems for SpaceX as it did for Boeing. Foremost among these problems was the development of new parachutes. In 2013, the Cargo Dragon's Mark II parachutes began tests with the new Crew Dragon off the California coast. During an abort, the parachutes would be released into turbulent air. Being dropped from a sky crane at 2,500 meters simulated these conditions. At this early stage, SpaceX saw parachutes as a backup system. The company's ultimate intention was to land the capsule propulsively. The new capsule is fitted with 8 Super Draco engines. These are used for a launch abort. A significant difference in the design compared to the Boeing Starliner has these engines mounted to the capsule itself, and they will return to Earth. Boeing's abort engines are discarded with the service module before re-entry. Because the Crew Dragon retains these powerful engines, they could be used to control the craft's descent for a soft landing. The company felt it would soon be recovering its Falcon 9 first stages via propulsive landings, although to outsiders, it may not have seemed that way. Each failure provided valuable data which brought the concept of reusability and huge savings closer. SpaceX soon abandoned the idea of its capsules landing propulsively. The time and development costs involved in making the system work reliably were just too great. The company would continue to rely upon parachutes. Early tests continued with the Mark II parachutes attached to a test article that weighed the same as the Crew Dragon. Parachute testing turned out to be unpredictable, and SpaceX began a fly, test, fix approach. This led designers to move to a Mark III version with stronger lines and a different stitching pattern. NASA showed some frustration regarding the parachutes. They had set back both Boeing and SpaceX, and the commercial crew program was years behind schedule. The space agency had to pay Russia $85 million for every astronaut's ride to the ISS, and they were becoming impatient. Elon Musk gently reminded NASA that the Apollo program had also struggled with parachutes.
6.
Even before
5,
final verification
4,
of the parachutes,
3,
SpaceX
2,
tested the pad
1,
abort system.
launch.
Prototype Dragon C-200 craft had been fitted with weights to simulate a crew, including a dummy astronaut rigged with G-force sensors. A complex series of events had to be triggered in a very different sequence from the usual return to Earth. Though a fuel mixture anomaly in one of the engines meant there was a slight underperformance in thrust, the test was successful. However, unlike Boeing, SpaceX would test the system again, but during an actual flight. The Falcon 9 launcher would carry the Crew Dragon, but this rocket was being upgraded regularly. In 2015, the first full-thrust Falcon 9 was launched. It was partially an experimental flight. The first stage was fitted with landing legs. The rocket carried 11 Orbcomm communications satellites, but that's not what the crowds of SpaceX employees had come to see. Even before the satellites had been deployed, cameras picked up the returning first stage. This was the 8th attempt to bring the expensive first stage back to the ground, yet seasoned space experts remained skeptical. Just the 20th flight of the Falcon 9, SpaceX, the young company with peculiar ideas, is proving itself an innovator in a very conservative industry. Soon, boosters that had lifted heavier loads were returning to drone platforms far out in the Atlantic. While safely retrieving the first stage was a triumph, this was only half the task. The Space Shuttle had returned as well, but its time-consuming refurbishment made it uneconomical. Before a stage could safely be reflown, SpaceX began exhaustive tests to see whether the various systems had suffered from the flight. Over its evolution, the Falcon 9 has almost doubled its power. There have been refinements to the engines, but most of this extra thrust has come about by chilling the fuel and oxidizer. The colder liquids contract, allowing more propellant to occupy the same space. In 2017, the Block 5 version that would carry astronauts made its debut. NASA required 7 flights without design modification before it would certify a rocket as suitable for human spaceflight, and SpaceX declared that this would be the final version of the Falcon 9. The Block 5 has changes to the octaweb structure that holds the engines to allow easier and faster access for inspection, and thermal shielding around the engines has been upgraded. In addition, some parts have been left unpainted to save weight. The extra power would be partially offset by the Block 5's heavier landing legs and more robust grid fins. Flights reusing first-stage boosters became routine, and turnaround time between relaunch of an individual booster had been cut to less than 2 months. In November 2020, booster B-1049 safely returned after its 7th launch. The breakthroughs being made by SpaceX were accompanied by new working procedures, and some of these practices gave NASA concerns. The idea of sending astronauts on a used rocket worried the space agency. SpaceX reassured their client by saying that only new rockets would be used for astronauts. Boeing had no such problem because their Atlas V cannot be retrieved. Yet from the beginning, they had sold NASA on a Starliner that could be used 10 times. Ultimately, SpaceX's safe record convinced NASA, and their contract was amended to allow astronauts to fly on reused rockets and spacecraft. However, there was one crucial area where Boeing and SpaceX differed. Both the Falcon 9 and Atlas V burn flight-grade kerosene, known as RP-1, with liquid oxygen in both the first and second stages. For an Atlas V, liquid oxygen begins flowing into the first stage tank 2 hours before launch. Its temperature is just below its boiling point. The RP-1 at ambient temperatures will already be loaded from the wet dress rehearsal several days earlier. As the liquid oxygen boils, it vents in clouds around the rocket and is constantly replenished. Only after the bulk of the fuel and oxidizer is loaded would the crew be allowed to enter the spacecraft. Because of the boost to the Falcon 9's engines, fuel and oxidizer must be much colder, and they are loaded just 30 minutes before launch, leaving less time for them to warm to the ambient temperature. Known as load and go, the technique requires the crew to be strapped into their spacecraft before the fueling begins. The Space Shuttle and previous manned flights, both American and Russian, all had crews entering their spacecraft after the rocket had been fully fueled. SpaceX's departure from this time-honored routine had conservatives at NASA concerned. While SpaceX maintained its procedures for loading propellant could be amended, they pointed to the successful demonstration of the Crew Dragon's pad abort system, something the Space Shuttle did not have. Ultimately, NASA agreed to the different fueling routine. The space agency had gone to great lengths to get their contractors to innovate, and it seemed foolish to block an important new technique, especially as SpaceX's safety record was sound. In 2015, 1 year after the commercial crew contracts had been awarded to Boeing and SpaceX, a NASA report stated that American astronauts would travel to the ISS on American spacecraft as early as 2017. But in December 2018, a Russian Soyuz craft was being prepared to take crew to the International Space Station. At this stage, not even test flights had been made by either Boeing or SpaceX. The launch and rendezvous with the ISS were perfect, and NASA managers continued to book seats on the Soyuz for several more years. While technical issues had delayed both commercial crew projects, SpaceX seemed to solve their issues quicker. Some felt that problems Boeing was experiencing with its airliners had distracted the company's management. Though Boeing's Starliner had been drop tested in water, techniques for marine recovery in case of a launch abort still needed to be worked through. By early 2019, SpaceX's Crew Dragon was ready to fly, while Boeing's first flight test was still months away. This mission was known by NASA as SpaceX Demo 1. On board were 180 kilograms of supplies and equipment, and Ripley, a dummy astronaut packed with sensors. After it had reached orbit, the spacecraft carried out phasing maneuvers, approaching and backing away from the ISS before making its final approach. On its 18th orbit, the spacecraft moved from the 20-meter hold point and began edging toward the forward port of the ISS's Harmony module. The automated docking went without a hitch. Crew from the ISS unloaded the craft and began checks of the capsule for any damage or anomalies. After 8 days, the hatch was closed. The capsule undocked and slowly backed away before making the deorbit burn that began the journey back to Earth. The splashdown on target off the coast of Florida completed a flawless mission. Though there was still data to be examined, the Demo 1 flight showed that the Crew Dragon was ready to carry humans. It was months before Boeing was able to respond. But before the Starliner could make its orbital flight test, it had to demonstrate that the launch abort system and the hydrazine thrusters that had been so problematic were now reliable.
2, 1, 0. On track. Comet cut off.
After 5 seconds, the abort engines shut off and the capsule's steering thrusters positioned the craft for parachute deployment and service module separation. Data gathered during the test would reveal whether the system would be able to perform during an in-flight emergency.
Broke parachute's mains. SM7.
Performance was good, except that again only 2 parachutes unfurled. This time it was not intentional. A linking pin had not been fitted, but engineers were now confident that the craft could survive a landing with just 2 parachutes. While the team had a large volume of data to analyze, it was clear that the emergency system had performed as intended and the test was declared a success.
Airbags inflating.
The next major test of the Starliner system would be an unmanned flight to the International Space Station. If that went well, it would be followed by a crewed test flight, which would be the final stage of spacecraft validation.
CM touchdown.
It's not just the spacecraft that must gain special certification to carry humans. The Starliner will initially fly with the Atlas V launcher, although it has been designed to function with a variety of comparable rockets. The Atlas V, configured here for the launch of a tracking and data relay satellite, has a proud record. Its first stage is powered by the Russian-built RD-180 engine, which discharges via 2 combustion chambers. By adding extra strap-on boosters, it can be adapted to a wide range of missions. For Starliner launches, it will be fitted with 2 solid-fueled boosters. The whole Atlas V had to be set up in a completely new way, and most of those changes are in the Centaur upper stage. This is a high-energy stage powered by liquid hydrogen and liquid oxygen. At the top of the Centaur, located beside the guidance computer, are 2 monitoring computers, an active unit and a spare. Known as the Emergency Detection System, it can pick up symptoms of imminent failure and initiate an abort. Another crucial change to the Centaur is the introduction of 2 RL-10 engines instead of the Atlas V's usual configuration with just a single engine. Several astronauts due to fly at the beginning of NASA's commercial crew program were at a test firing of the latest RL-10 that would be so important to Starliner missions. Again, Boeing is tapping into 5 decades of experience with the RL-10. The engine was at the forefront of the effort to harness hydrogen as a fuel. While it is the most energy-dense propellant, learning how to work with a liquid that must be maintained at or below minus 253 degrees Celsius was extremely challenging. The 2 upper stage engines enable the Starliner to follow a shallow trajectory that lends itself to a safe abort at any point in its journey to orbit. When the Starliner separates from the upper stage, it will not be on a sustainable path. While at this moment the craft will be securely above the atmosphere, without further adjustment, the low point of this orbit will bring it back into the atmosphere, meaning deceleration and re-entry. After a precisely timed delay, a 40-second burst from the capsule's orbital maneuvering engines will put the craft safely on course for rendezvous with the International Space Station. Though the Starliner's first test flight will only carry a dummy astronaut, it will follow this shallow trajectory even though the emergency detection system will be disconnected. The abort parameters would be fine-tuned with the acquisition of more data from the scheduled test missions. In November 2019, Boeing began stacking an Atlas V for the Starliner's first flight. NASA insiders, who initially saw Boeing as the program's pace setter, had gone quiet since the aerospace giant was clearly lagging behind SpaceX. A recent report by NASA's Office of Inspector General increased the pressure on Boeing when it questioned extra payments to the company to accelerate lead times for its contracted 5th and 6th crewed missions, even after it had received almost double the development costs of SpaceX. The aerospace giant was confident that a successful demonstration mission would neutralize any criticism. In December 2019, the Starliner was ready to fly. NASA called this mission the Boeing Orbital Flight Test. Parameters laid down by NASA meant the flight had almost identical objectives to SpaceX's Demo 1. The craft carried an instrumented dummy, this time called Rosie, and a small amount of cargo to be delivered to the ISS. It would provide a direct comparison between the performance of the 2 new commercial craft. The Atlas V performed reliably with the Starliner following its ascent profile accurately, and the Centaur upper stage separating from the spacecraft as intended. At this stage, the craft was to coast till 31 minutes after launch, when its orbital maneuvering and attitude control thrusters would perform an orbital insertion burn. But this did not happen. The mission elapsed timer had an 11-hour error, and the craft's maneuvering thrusters began making unnecessary firings, wasting fuel. Compounding the problem, communication at the critical time was intermittent. NASA's low Earth orbiting spacecraft transmit and receive signals via an array of 10 tracking and data relay satellites flying in high geosynchronous orbits. Because the Starliner didn't know where it was, its antenna was pointed inaccurately. Ground controllers could not get a signal to the craft to correct the thruster firings until too much fuel had been consumed, leaving it unable to reach the ISS. Software experts checking for other bugs found errors in the sequence governing the separation of the service module from the crew module. This was corrected, avoiding what could have been a collision between the two modules after separation. The mission, originally intended to extend over 6 days, was terminated after just 2. The re-entry and return to the ground were successful, with the Starliner safely descending under parachutes to the White Sands facility in New Mexico. NASA people were keen to put a positive spin on the Boeing mission, but behind the scenes, analysts were beginning to understand the extent of the problems uncovered by the orbital flight test. An investigation began immediately and was followed by a full-scale safety review. NASA wanted to understand how so many fundamental software errors had been missed in pre-flight testing. Ultimately, 80 corrective measures were recommended, with Boeing declaring it would repeat the mission at their own expense. In the SpaceX camp, things were progressing smoothly. There was just one more test, an in-flight demonstration of the launch abort system before astronauts could fly.
10, 9,
Among those present at the launch were astronauts Bob Behnken and Doug Hurley, who would fly on the first manned test flight.
0.
Everything went as a conventional launch until a point where the rocket was experiencing maximum dynamic pressure when the first stage engines were commanded to shut down. The safety system registered the anomaly and triggered the abort sequence. The unstable rocket soon exploded, and the rest of the emergency sequence went as expected. For the SpaceX team, the final step in receiving NASA certification for the Crew Dragon was the Demo 2 flight carrying 2 astronauts.
Splashdown.
Spacecraft Commander Doug Hurley and Joint Operations Commander Bob Behnken, who would fly as the Dragon's first crew, were veterans of the shuttle program and military test pilots. While the Dragon capsule can function automatically, the Crew Dragon configuration allows astronauts to take manual control via an array of touchscreens. It was argued that had there been a crew on Boeing's orbital flight test, the software faults could have been overcome. Testing the new spacecraft was only part of their mission. Once on the ISS, Hurley and Behnken would have to contribute as crew members. But as the public face of the return of an American spacecraft, there was also a certain amount of public relations work.
And the Soyuz has been a great vehicle to get our folks to and from the space station. The Russians have been great partners, but it's important for the United States to have its own launch capability.
It's really been the dream of all of us to participate in the test of a new vehicle. And a vehicle like a spacecraft is probably the gem, if you will, of a career for folks. And so I would have been embarrassed as a test pilot school graduate to not have jumped at the opportunity if it was offered to me to fly new spacecrafts.
Tropical Storm Bertha canceled the first launch attempt. But finally, on the 30th of May 2020, preparations went smoothly. The 2 astronauts emerged through the doors that had seen the start of so many historic launches. 2.5 hours before launch, Hurley and Behnken were strapped into the capsule above a Falcon 9 that had not yet taken on fuel. the first time that the load and go technique had been used with a crew on board.
4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA. Go SpaceX. Godspeed, Spot and Dog.
Soon the spent first stage separated and successfully returned to the Atlantic drone ship. After separation from the upper stage, Hurley and Benkin took manual control and tested their craft's ability to roll, pitch, and yaw. Automated docking with the ISS was as expected.
And with that endeavor, welcome
The crew
to the
was
International
welcomed
Space
aboard the
Station. Please come
ISS,
aboard.
but at this stage, nobody knew just how long they would be staying.
Got a whole bunch
Depending
of very,
upon the condition of their
happy and grateful
spacecraft
people making their
and the
way into
readiness
NCT
of the
right now.
next Crew Dragon capsule that would bring the first routine crew rotation, the two astronauts would stay in space for between 30 and 119 days.
It's a great-looking photograph. So thanks
After
for that.
NASA
Stand
gave
by
the
one.
green
We'll
light,
call you when we're
Hurley
ready
and
for the event
Benkin
in the next
settled
few
into the
seconds.
routine of ISS crew. Bob Benkin and Chris Cassidy made 3 spacewalks to replace space station batteries. The Demo 2 astronauts worked on the station for 62 days before re-entering the Crew Dragon for its return to Earth.
Dragon SpaceX, undock sequence commanded.
This represented the final stage of the Crew Dragon's testing.
Dragon departing.
Like every other
Dragon
aspect of this
SpaceX,
demonstration
separation
flight,
confirmed.
separation from the cargo trunk, re-entry to the atmosphere, and the descent under parachutes went according to plan. On November 10, 2020, the Crew Dragon and the Falcon 9 received NASA certification. 6 days later, the first routine flight to the ISS by a Crew Dragon capsule delivered a crew of 4.
Here it comes.
Here they come, our CFT crew
On June
taking their
5th,
first steps
2024,
outside for their
Butch
historic
Wilmore
flight
and
test
Sunita
to the
Williams
International
finally
Space
made the
Station.
Starliner's first
7,
crewed test
6,
flight.
5, 4, 3, 2, 1, ignition, and liftoff of Starliner and Atlas V, carrying 2 American heroes, drawing a line to the stars for all of us.
During the flight to the ISS, helium leaks were detected in several thrusters, and it became clear reliability issues remained. For safety reasons, the Starliner was returned to the Earth without the crew, who were left waiting in space for a further 9 months before returning to the Earth on a SpaceX spacecraft. The Boeing capsule's problems remain unresolved. A tentative 2026 launch date has been proposed for the next flight.